Welcome to this session on permutations and combinations. In this session, we will take a look at some questions based on digits. So, what are questions based on digits? Well, generally, such questions seek to find out how many numbers can be formed under a set of given constraints. And what can those constraints be? Those constraints can be any one of these things or even more. For example, the constraint can be on the number of digits. So you can only have certain digits and you may not have certain other digits. The constraints can be on the number of ways or on the way the digits may or may not appear. For example, one condition can be that 5 and 7 are always next to each other and we are required to find out the number of numbers. The constraints can also be on the repetition of digits. So whether repetition of digits is allowed or repetition of digits is not allowed. And there can be many more constraints. These are just a few examples of constraints. Let us go right into one question. So the question is, how many three-digit numbers can be made? Let us try to solve this question. In order to solve, let us first of all take a look at what are the constraints in this question. So towards the right of this partition that I have drawn, we will list out all the constraints, and on the left we will try to solve the given question. So the first constraint, and this will be a constraint for almost every question, that the total number of digits that we can use is 0 to 9. So not really a constraint considering that we are solving in decimal numbers. Another constraint is that the numbers have to be 3-digit. So we cannot have more than 3 digits for this particular number. So let us try to solve them. Now to solve this question, we need to know how many tasks are there with us. So the number of tasks are 3. And what are these 3 tasks? To fill the units place. Then the second task is to fill the tens place. And the third task is to fill the hundreds place. And because each of these are compulsory, therefore we can say that we have to fill the hundreds place and the tens place and the units place. So in how many ways can you fill the hundreds place? Now it is necessary here to fill the hundreds place first because one of the digits is 0, and by common knowledge we know that 0 cannot appear in the hundreds place of a 3-digit number. So obviously, how many digits can be fit on hundreds place? So all digits from 1 to 9. So we have 9 choices to fill the hundreds place. What about the tens place? Now, because repetition, there is nothing mentioned about the repetition of digits. Remember, in such questions, if nothing is mentioned about the repetition of digits, then you need to look at the context of the question, or you have to assume that repetition of digits is allowed. So nothing can be obtained from the context which tells us that repetition may not be allowed. Therefore, we will assume that repetition is allowed in solving this question. Now, how many digits can fit the tens place? Obviously, there is no such constraints of not having a 0 on the tens place. So, all 10 digits can occupy the tens place. What about the units place? Units place, again, there is no constraint, so we can have any one of the 10 digits that fill the units place. And as I told you earlier, that every AND can be replaced by a product, by a multiplication sign. So our answer will be 9 into 10 into 10. That is 900 3-digit numbers. And obviously, because this is a very small number, we can actually count and find that number of three-digit numbers from 100 to 999 is indeed 900. So we saw how we applied the basic principles of fundamental principle of counting and solved such a simple question. Now let us move to another similar question. So the next question, how many three-digit numbers can be made? Repetition of digits is not allowed. So here another constraint has been introduced. So how do you solve this particular question? Once again, let us list all the constraints on the right hand side of this partition. So what is our constraint number one? So the first constraint is that once a digit is used, it will not be used again. The second constraint, once again we have to form a three-digit number only. So let us once again try to see how to solve this question. So once again we have the question of filling these three positions, units, tens and hundreds, with our digits 0 to 9. So let us fill the hundreds place first. This is your hundreds place. So how many digits can occupy the hundreds place? We can see that all the digits from 0 to 9 except 0 can occupy. So the number of choices we have to fill the hundreds place is 9. Now one digit has already occupied the hundreds place. So it is not available to us for any further placement of digits. Now let us try to place the tens digit. So in how many ways now we can place the tens digit? Again, the total digits available are 0 to 9, which are 10 in number. But out of these 10, one digit has already been placed at the hundreds place. So therefore, the number of digits remaining are only 9. So which means the number of digits left for the units place are 8. Because out of these 10 digits, one digit has been placed at the hundreds place and one digit has been placed at the tens place. So these two digits are not available for placement at the units place because repetition of digits is not allowed. And again, all the three tasks, placement at the units place, placing at the tens place, placing at the hundreds place, are compulsory. So therefore, we will have a multiplication sign in between. So the total number of numbers of three digits which are possible without repetition of digits is 648. That is 9 into 9 into 8. So with this we come to an end of this particular session of circles. If you wish to watch more videos or if you wish to know more about the topic, please log on to our website pfindia.com. If you want to ask a doubt, please write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.